One last example in this section. This is relating distance and speed and time. If an object travels at a constant speed, and that speed is given by the formula, the speed is the distance traveled over the time elapsed. And if the object is not traveling at a constant speed, this formula is going to give you the average speed of the object over the time period in question. Let's look at an example. A car traveling at a constant speed leaves Mathville at 1 p.m. and reaches Calcville 60 miles from Mathville at 1:50 p.m. And let's assume that 60 miles is the distance. It's not 60 miles as the crow flies, it's the distance along the road that the car has traveled on, assuming the car is traveling on a road. So, at what speed was the car traveling? Well, it's a constant speed, so it's going to remain the same. And that speed is going to be the distance traveled over the time it took to travel that distance. And that turns out to be, well, they went from Mathville to Calcville in 50 minutes. And so here we're measuring time in minutes. And the distance traveled was 60 miles. So they traveled 60 miles in 50 minutes, and that's 6 over 5 miles per minute. So that's equal to 1.2 miles per minute. Now we normally think of speed of cars in terms of miles per hour. And so the miles per hour here, if I want to translate this to miles per hour, it's 1.2 times 60, because there's 60 minutes in an hour, miles per hour. And that's equal to 72 miles per hour. So this car was traveling at a constant speed of 72 miles per hour, or 1.2 miles per minute. Let d be the distance traveled by the car from Mathville at time t. Now the value of d is going to depend on what the time t is, where t is t minutes after the car left Mathville. So 1 minute after the car left Mathville, it had traveled 1.2 miles, 2 minutes 2.4 miles, 10 minutes it had traveled 12 miles. Write down the linear relationship between d and t. Well, when t is 0, the car is just about to leave Mathville, and it has traveled 0 miles. And for every minute, that car travels 1.2 miles. And so after t minutes, the car has traveled 1.2 times t minutes, sorry, 1.2 times t miles after t minutes. So therefore the distance traveled is equal to 1.2 times t. And this is a linear relationship. If I graph this on a plane where the axes are marked t and d, its graph is going to be the graph of a line which passes through the point 0, 0. For what values of t is this relationship valid? Well, this is only true. All that we know so far is that this car is traveling at a constant speed between Mathville and Calcville. We know nothing else. It might have stopped in Calcville might have stopped in Mathville. So we only know that d equals 1.2 t. Well, it's leaving Mathville when t is 0, so it's for t 0 less than or equal to t, and it arrives in Mathville after 50 minutes, and that's when t is 50. So this is true. This car has traveled at this constant speed between Mathville and Calcville, and that's for t between 0 and 50. And we can draw a graph. This line is going to go through the origin. We're talking about a relationship between d and t, so we label our axis as d, which is our dependent variable, and our horizontal axis is t, which is time. Remember, t is measured in minutes, and it's always good to keep track of what your units of measurement are, and d is measured in miles here. And I know when t is 0, then d is going to be 0. And I also know that when t is 10, d is 12. I'm going to mark off the axes in increments of 10. And the relationship only holds for t between 0 and 50, so it's along this portion of the t-axis. When t is 0, d is 0, so the point 0, 0 is on the line, and when t is 10, d is 12, and when t is 50, then d should be 60. Hopefully these 3 points are on a straight line. If not, I've made a slight error in judgment here. And that's the graph of this relationship, and notice that I stopped right here when t was 50 because the relationship ends there, and it begins here at t equals 0. So this is a model of what's happening with this car between 0 and 50 minutes between Mathville and Calcville.